solving system of linear equations using Laplace transform. Okay, we do this one. This is a classic. Then we do the modern type, okay, later on using eigenvalues, linear algebra. Okay, so this is the idea. This method is going to be called algebraic method. So what you're going to do, a system of two differential equations in two unknown would be given to you. So one of the unknown function is f of t, I call it. The other one is going to be g of t. In your book, they call it x of t, y of t. Then what you are going to do is, in order to do it, because this equation would involve the function and the derivative. So you are going to take the Laplace transform of both equations this time. When you take the Laplace transform, your system of the equation would be changed into the algebraic system, and your unknown are going to be Laplace of f of t and Laplace of g of t. So use addition method or substitution method to find the Laplace of the unknown functions, and then use the Laplace transform to do it. It's like a doubling, your effort, if you like, because previously you did it for one equation, then you are going to do it twice, okay, to get these numbers. It can be of any order. The second order is very popular in application. It takes time. We may try one of them, okay, but mostly on the test because it takes time. So we just give you of the first order rather than the others, okay? Then you are going to learn another method when we get to the chapter 8. So I just give you a brief idea of how this system algebraic work is working, and then we give you a couple of examples. We give you one of them on on your test. So that's it. So to solve a linear system, okay, a system of two linear differential equations. Okay, two linear differential equations with the unknown function, with the unknown functions f of t, this is the notation I'm going to use, and g of t, okay, using Laplace transform. Laplace transform. It's the way we're going to do it. You see, step one, we're going to take the Laplace, take the Laplace transform of both equations. Simplify, and convert it into a system of equations. Okay, a system of equation with the unknown functions. You see, the unknown functions are going to be Laplace of f of t, okay, and Laplace of g of t. This is going to be the case. Now your equation reduced into the, okay, algebraic form. Okay, step two, you are going to solve the resulted equation. Solve the algebraic that you got, algebraic system in two variables Okay, using usual method, using addition method, addition or substitution. Substitution method. Okay, to evaluate, this is it. You're going to evaluate the first one is going to be Laplace of f of t. When you find it, the result will be f of s, a function. The second one, when you find it, Laplace of g of t would be g of s. So take the Laplace inverse to find the solution, okay? So the solution of the system, the solution of the system is going to be, this is it, f of t is going to be equal to the Laplace inverse of f of s, and g of t would be equal to the Laplace inverse of g of s. That's it. It's a system. You have to do it twice. It depends on the nature of the problem. You may have a homogeneous equation or you may have non-homogeneous equation. Okay, it depends on the application that you have for your system. Give you a couple of them to see to get an idea of what we're going to do it. It takes a little bit of time to do it, but it can be done. For some special cases, we are going to do the second method in chapter 8 for the rest of the course. Okay. Give you example how we're going to do it. Okay, example. We want to solve the system. Okay, solve the system using Laplace transform. Okay, using the Laplace transform. This is the system. We usually use x of t and y of t, but then you can change it, or you can stay with those methods. And this is it. The first equation is true. Okay, so the first equation is 2x prime. X is a function of t, like when using physics, you use x and the y. 2x prime plus y prime minus y equal to t. This is your first equation. And the second equation is x prime plus y prime equal to the t squared. Then you have to be given an initial condition. Initial conditions are x of 0 is equal to 1. Okay, and y prime of 0 is equal to the 0. Okay, so this must be y of 0. Okay, x of 0 is equal to 1 and y of 0 is equal to 1. So that's a given system. You can stay with the same notation if you like, but I prefer change it to the function type f of t, g of t. If you don't like it, you can work with this type of notation. You just go ahead. Because that would be a little bit confusing because we use the lower x for the function. And when they want to talk about the Laplace transform, use the uppercase. So it would be very much involved. But I prefer f of t and g of t as a, yes, what's the question? Yeah, inverse, yeah. Laplace inverse. I just used the different, but it's the same one. Okay, so quickly I change it to the new notation, solution. So I'm going to suppose the solution are going to be of this type. Okay, I suppose that x of t is equal to the f of t and y of t is equal to the g of t are the solution of the system, okay, are the solutions of the system with the initial condition. Okay, my initial condition is that the f of 0 is equal to 1 and g of 0 is equal to this. Okay, so I go back and change the system into this type of notation, which is easier. Okay, I have to go to the next page just to change this system. I change them and then I find the Laplace transform of each one of them. Okay, are you done? So going to the changing the system into the familiar notation. So this is the system that we have. Okay, the first part was 2x prime. So I'm going to have 2f prime of t, 2f prime of t plus g prime of t minus g of t equal to the t. This is my first equation. And the second equation, I have f prime of t plus g prime of t, okay, equal to the t squared. Now that's the system. Take the Laplace transform of both equations. So take the Laplace transform. So this is what you're going to have. It's going to be, it's a linear. So 2 Laplace of the f prime of t plus Laplace of g prime of t, okay, minus Laplace of g of t is equal to the Laplace of t. That's the first equation. Do the same thing to the second. Laplace of f prime of t plus Laplace of g prime of t is equal to the Laplace of t squared. That's a step one. You have to change those f prime, you know that, into the Laplace transform. So continue. This is going to be what? I just read it. Laplace of f prime of t would be s Laplace of f of t minus f of 0. I multiply by 2 at the same time. So that can be 2s Laplace of f of t. Okay, minus 2 times. Okay, this is going to be minus 2f of 0 for the f prime. Okay, then we continue to get these parts. I just make sure you get it. I have the right solution. Okay, that's it. So we continue with the second one. So the second one is going to be s Laplace of g of t. Okay, minus g of 0. And then you have minus Laplace of g of t. Then Laplace of t. What's the Laplace of t? 1 over s squared. That's the first one. Okay. Check the second one. So for the second one, we get s Laplace of f of t. Okay, minus f of 0. And this is going to be Laplace of g of t minus g of 0 and Laplace of t squared. What's the Laplace of t squared? 2 over s cubed. That is going to be the case. Okay, bring the initial condition. So the initial condition that f of 0 is equal to 1 and g of 0 is equal to the 0. So apply this condition and continue. So this is it. F of 0 would be 1 here. Okay, g of 0 is 0. So the first one would be changed into the 2s Laplace of f of t. Okay, minus 2 plus S Laplace of G of T. Okay, minus Laplace of G of T equal to the 1 over S squared. That is going to be the case. For the second one, it's going to be S Laplace of F of T. Okay, F of 0 is 1. And this is going to be plus the Laplace of G of T. And the G of 0 is 0. So that gives you 2 over S cubed. This is it. Now, simplify it. So the simplification is going to be, because remember your unknown is Laplace of F of T and the G of T. So over here, I have 2S Laplace of F of T. For the G, you see Laplace of G of T and the Laplace of G of T, I'm going to factor out. So that gives me S minus 1, Laplace of G of T. Okay, I'll move everything else to the other side. So I have one more S squared, and this is going to be negative 2, make it to the positive. Yes?
Other than the first system, we're taking the Laplace of G prime of T. So shouldn't we have S times the Laplace of G of T in the next?
We have?
For the second equation.
Second one.
We have the Laplace of G prime of T. So then in the
This
next
is,
we have Laplace of G of T. And I think that's supposed to be multiplied by that.
oh, this one you mean?
Yeah.
Oh, okay, thank you. S, yes, you are right, thank you. S. Okay, everything is all right. So what I did for this one, I factor out the Laplace of G of T. So that's the first one. We arrange the second one. The second one, we get the S Laplace of F of T. And we have S Laplace of G of T. Laplace of G of T. So this is 2 over S squared, S cubed, and you move the 1 to the other side. You see, now we change it into the algebra. Because we have a system of 2 equations, 2 variables, but the variables are F of T and G of T. So from now on, algebraic system. Use this addition method to find it. You have to eliminate one of them. Okay, eliminate one of them, whichever is going to be easier. In this case, it's easier to eliminate Laplace of F of T. Because simply this is the 2S, you need a negative 2 here. To be able to cancel out the Laplace of F of T. Okay, so I'm going to multiply the second one by a negative 2. Then I add them together. Then you'll be able to, okay, cancel out the Laplace of F of T. And then we can do the job. Okay, so it's algebra from now on. So this is it. So the first one would be repeated again, 2 Laplace of F of T plus S minus 1 Laplace of G of T. Okay, and that's a 1 over S squared plus 2. In the second one, you multiply by a negative 2. So that gives you negative, okay, negative 2S Laplace of F of T. They will cancel out. And this is going to be negative 2S, Laplace of G of T. And the other side, you have to multiply both sides. So that gives me negative 4 over S cubed minus 2. Okay, now we are ready to add them together to cancel out the Laplace of F of T. So these two will cancel out the leftover. The leftover is going to be S minus 1 times the Laplace of F of G of T. And from the second one, minus 2S Laplace of G of T. And on the other side, the 2 and 2 will cancel out. So the leftover is going to be 1 over S squared minus 4 over S cubed. Okay, that's the one. So factor out the Laplace of g of t to simplify it. So we factor out the Laplace of g of t. What's going to be the leftover? The leftover is going to be s minus 1 minus 2s times it by Laplace of g of t. Okay, and the other side is 1 over s squared minus 4 over s cubed. So combine the like terms here, s minus 2s would be negative s. So that give you negative s minus 1. Laplace of g of t is equal to the 1 over s squared minus 4 over s cubed. Okay, so this is going to be the case. To find the Laplace of g of t, you have to divide. Okay, you can pull out the negative sign here to make it s plus 1, then do the job. Okay, so you can, if you like, you can multiply both sides by a negative 1. That would be easier for the rest to factor it. So that give you s plus 1 Laplace of g of t. Then on the other side, I'm going to have a 4s cubed minus 1 over s squared. Okay, now I can find the Laplace of g of t. Laplace of g of t, divide 1 by 1. So it's going to be equal to, you get the 4 over, okay? So it's going to be 4 over s cubed times s plus 1 minus 1 over, that give you what? It's going to be s squared. S squared times s plus 1. Okay? And this is going to be the case. You have to find the Laplace inverse to get this number. Okay? You need to, use partial fractions to get these numbers to be done. Even if you simplify it, that would be easier because it doesn't matter. You can, you can do it as is. But if you simplify this part, a kind of a common denominator type, that would be easier to just take care of one part because I combine them together, then I break it. Because this is, it's going to be not, it's going to be easier. If you find the common denominator, the top would be 4 minus, and this would be simply minus what? Minus s. Okay, I find the common denominator. The common denominator would be s cubed times s plus 1. So the top would be 4. Over here, you have an s on the top only. So g of t is going to be equal to Laplace inverse. Okay, Laplace inverse of 4 minus s over s cubed over s plus 1. So you have to take care of this. Okay, Laplace inverse of this function. You have to break it into the partial fractions to find the g of t. You have a repeated factor of the x cubed and the s plus 1. Any question? Write it down. I go to the next page and I break it. And the numbers, I just give you the numbers because you have to do it yourself. Yes.
When you subtracted both functions from each other on the top,
Yes. Which one?
or like into the red line, right under it.
Yes.
How did you get minus 2 as part of the
This one. You see, I multiply the second by my negative 2 to simplify. Which one is it? I don't see it.
This one's right after the red line when you subtracted both functions.
So when I subtract the both function, you see these two would cancel out.
Right.
Then I have, this is the first one minus the second one. Okay, this is the first function and this is the second function. I add them together.
How did you get x minus 1 minus 2s? Oh, did you just like factor out?
You factor it out. You combine the like terms. Since it's not number, you see, you factor out to simplify it. Okay, now let's do it. This is it. So you have to find the partial fractions of this one. Okay, so you have the 4 minus s over s cubed over s plus 1. You know that you have a repeated factor. This is going to be the 1. You need the s. You need the s squared. You need the s cubed. And you need the s plus 1. Okay, and the numbers on the top. It's going to be A, B, C, D, A1, A2, A3, A4. You better, because you have two numbers, s equal to the 0 when you find the common denominator, s equal to 0, s equal to -1, and you are going to be short of the numbers to do it. Yes.
For the one that has s squared and s cubed in the denominator, why would we have the numerator? Like yeah, why would you split up?
It's a repeated factor, you have to do it over here. You can break it if you like into the 1 over x cubed plus the other part, s plus 1. But it takes time because if you put the x cubed, you can try that one too to get these numbers. But this is the usual practice that we do it. Because s cubed is a repeated factor. When it's a repeated factor, you have to repeat it. 1 over s squared, etc. To get these numbers. Yeah.
Okay, I
Yeah.
thought that when you had a power on the bottom, you had to bring the top going. Yeah, that's what I had, but it's not necessarily.
No, the repeated factor is of the linear factor. The degree is 1. Since the degree of, if the bottom is non-factorable, you are right. If it's the non-factorable, the top is 1 less. But when it's a repeated factor, you repeat the s. Okay, repeat factor. But anyway, this is going to be the case. And I just give you the number, but I give you the form here. So it's going to be A1. Okay, this first one, the common denominator would be the same thing. Okay, that's the one. Then on the, okay, so what we're going to have on the top, this one you divide by s, so it's going to be A1 s squared times s plus 1. This is going to be A2 s times s plus 1. This would be A3 times s plus 1. And the last one would be A4 times s cubed. You know, it takes time. So you let the top two equal to each other and you find these coefficients. Okay. You have two numbers, you know, s equal to the 0 and -1. You'll be able to find some of them. So this is it. Is equal to the 4 minus s. Okay, so you can pick the s equal to the 0, s equal to the -1. You need two more numbers. Okay, so for example, you can pick the s equal to 1 and s equal to 2, and these are going to be the solution. You can check it for yourself. A1 would be 5, A2 would be -5, A3 would be 4, and the A4 would be 5. You get these numbers.
Would this be something that we see on a test?
Yes,
Okay,
So this is a really long process, so whatever it's.
it's very long. Yeah, I told you the system of the,
So it's gonna be like,
of course.
no, the entire
Yeah,
test could be
yeah.
5 minutes.
Yeah.
Yeah, but you have to know the method really. See, that's one. There are different ways, you know, to simplify these type of ideas. At first, you have to get the idea, then you may try to do the better. But anyway, so this is it. So the Laplace inverse. Remember, this is just g of t. You have to do f of t too. So be patient. It's 4 minus s cubed over, okay, s plus 1. So there you are. You get the Laplace inverse of what? A1 is 5. So 5 over s, that's the first one, plus the Laplace inverse of -5 over s squared. Okay, A3 is 4, Laplace inverse of 4 over s cubed. and eventually A4 is 5. Laplace inverse of 5 over S plus 1. You know that those S square is going to be just T square, etc. Okay, the first one is Laplace of 5 over S, negative 5 over S square, 4 over X cube, okay, through the end. The first one, you pull out the 5, 1 over S. What is the Laplace inverse of 1 over S? T. So that gives you 5t. This is going to be the 5t.
Just one.
Oh, yes, you are right. 1.
Oh,
Laplace of 1 is 1 over S. It's going to be just 5. The second one is 1 over S squared, which is going to be t. Okay, so it's going to be minus 5t. That's the second one. And the third one, you know that this is n equal to 3. The top is just 3 plus 1. So this is going to be what? It's going to be 2t squared. 2t squared. And the last one is minus 5e to the negative t. So this is g of t. G of t is equal to the 5 minus 5t plus 2t squared minus 5e to the negative t.
Is it not plus 5?
Plus, yes, you are right. Plus. Okay, we didn't get any. A4 was 5, yes? Negative 5. It's a negative 5. Yeah, it's a negative 5. Negative 5. I know in my notes it's a negative 5.
Construction.
Hmm?
Last one. Yeah.
The negative 5 is the negative.
That's the one. Okay, you can use your calculator to find these coefficients. Yeah. So that's a G of t. You're not done. You have to go back and find f of t. Okay, that's it. It would be lots of fun to find f of t.
Can you just give us?
On the exam, you should just write FT equals that.
That's why you're suffering. Then you, when we get to the linear algebra part, you appreciate it.
Yeah, isn't it?
When you do the system without any, you know, when you go to linear algebra, really, it's going to be all linear algebra. Eigenvalues, metrics, done.
Yes.
Okay,
You could just solve for a third system equation, right? And then just.
but you know, but in practice, you may have to do this, and you have to do it. Okay, that's one. Okay, so let's go back to see which equation is going to be better to find f of t. Remember, this is the system that you have. Okay, you can use the substitution method going back into the. You see, this is the two equation that we have over here. So I'm going to substitute in this part. Okay, I substitute for g of t, then I can find f of t quickly. So I go to this second equation and I take care of it. Okay, so going to the second equation to find the f of t. So going back to the second equation. Okay, so what is the second equation? I have to rewrite it. It's a 2f of t minus, yeah, this is the second equation. It's a SL of f of t. You have it, I don't have it, I have to rewrite it. Okay, and I have the S of g of t plus S of g of t. Okay, and that was equal to the 2 over s cubed, 2 over s cubed plus 1. You see, this is the second equation you're going to have. So what you are going to do is you can divide everything by s, easily find the Laplace of f of t here. If you divide by s, Laplace of f of t plus Laplace of g of t is going to be simply equal to the 2 over s to the 4th plus 1 over s. So I did divide by s. Okay, so Laplace of f of t now is going to be equal to what? Is you move the Laplace of g of t to the other side. It's going to be negative Laplace of g of t. Okay, plus 2 over s to the 4th plus 1 over s. Okay, you already got the Laplace of g of t. You take the Laplace inverse. If you take the Laplace inverse of both sides, so that give you f inverse, f of, so that would be f of t equal to, this is Laplace of g of t. So if you take the Laplace inverse, that take you back to the, okay, to your function. So this is going to be negative g of t plus simply Laplace inverse of 2 over s to the 4th plus 1 over s. Okay, you can substitute for g of t now. And those terms, it can be easily found. So what's going to be f of t? F of t would be negative g of t. You take the Laplace transform of these two functions. Okay, so it's going to be plus Laplace inverse of 2 over s to the 4th and plus Laplace inverse of 1 over s. So this is going to be equal to negative g of t. So what's going to be this one? S to the 4th. Okay. It's going to be n is equal to 3. Okay, n equal to 3. We need the 3 factorial on the top, which is 6. You see, this is going to be 1/3 Laplace transform of 6 over s to the 4th. And 1 over s is just the Laplace transform of 1. So finally, it's a negative g of t plus 1/3. This would be t cubed plus 1. Now you can substitute for g of t to get the final answer. Okay. So what is going to be f of t? Equal to negative g of t. What is the g of t? This is the g of t. Okay. So it's going to be minus 5 plus 5t minus 2t squared plus 5e to the negative t. And you have 1/3 of the t cubed plus 1. So we simplify negative 5 and 1. The final answer is this one. F of t would be negative 4. Negative 4 plus 5t minus 2t squared. Okay, plus 5e to the negative t and the 1/3 of the t cubed. So that gives you the solution of the system. Okay. So as you can see, it's not bad, but it takes time. Okay, to be able to do it. I tried one more for you next time. Okay, to see. There is one a second order in your book. So you better look at that one. Okay.
I won't do it.
So how nice is the portrait credit on the next exam? Just asking for a friend, you know?
No, it's not bad really. You know it in case in future. Yeah.
So
Yes. That's
for this one, is there like an acceptable alternative to writing out Laplace of every single time to make it easier?
Yeah, you can call it f of s.
Oh, that's good.
Yeah. So you can quickly change the notation to the f of s and g of s.